Let's go over to the second one here. That intersection, enter, enter, enter. So I get 3.41. Okay, 3.410. So I found the intersection between y equals 0, which is my basically the x-axis, and the curve, right? And now I'm going to put down my keystrokes. That's normally how I will be doing it, right? So y2 is equal to 0, second, trace, 5. That's it. That's all you need for keystrokes there. The Y-intercept is as easy as just looking at the standard form, right? There are no brackets. That's basically what you're looking for. No brackets whatsoever. So that -4 is your Y-intercept, right? Or second, trace 1, x is equal to 0, right? That's another way of getting your Y-intercept every time. So if you're not sure, use this, okay? But I do expect you to know that you can just look at the standard form and get it. Vertex, by now you know that the vertex on a parabola is where it changes trajectory, right? So at this point is the max, the highest. So I'm going to have to go second, trace 4 for max, maximum. You have to go to the left of it. So if this is the vertex, you go to the left of it, hit enter. You go to the right of it, okay? Hit enter again, and now you've narrowed it down between these 2 points. So it's going to find it for you. So whenever it says guess, we just hit enter. So the maximum is found at 2, 4. Okay, 2, 4. And this is how we found it. Second, trace 4, because it's the max, right? If you want to write it down because you're not quite sure yet which one is max, right? 4 stands for max. And when you have one of these min-max, they just want the equation of the max, which is a horizontal line, goes through the y value of the vertex. No keystrokes there. Axis of symmetry is the vertical line that goes through the vertex and cuts it in half, right? It goes like this. So x is equal to 2. Domain, it would just be all real numbers or -infinity to +infinity. Range, y is less than or equal to, and the vertex tells you that, right? The highest value, which is 4. Or you're coming from -infinity up to +4 included. Make sure you have your squiggly brackets, right? Squiggly brackets around the set notation, as well as interval notation. And now we're going to graph it. Okay, so I'm looking at the x-intercepts, my y-intercept, and my vertex. So if I stay 5, right, 5 in each direction, that's fine, and I can use a scale of 1. So 1, 2, 3, 4, 5, and I'm just going to put a 5 here. That is enough in this case. 1, 2, 3, 4, 5. So I'm using 5 in each direction. Right? 1, 2, 3, 4, 5. I'm going to do the same thing here. I'm going to put x-axis, y-axis, so scale and label your axes. It will change soon. This will mean something within a context, within the word problem. And I'm just going to locate, right? 0.59 is right about there. 3.41 is right about there. Just less than half, right? Between 3 and 4. My y-intercept is at 0, -4. My vertex is at 2, 4. Okay. So I have those 3 points and I know it revolves around the vertex. So I'm going to go out a little bit and then down. And I'm going to go through and make sure it keeps on opening up. And then you go over it again, make it smooth. And then you go over and try to replicate, almost try to fold it along the middle here. And what I'm going to do here, in addition to everything we've done, is I'm going to draw the axis of symmetry. Which normally I don't need you to do that when I ask you to graph. X is equal to 4, and the min max, right? In this case, it's a max. That equation goes through 4. And that is the horizontal line, y is equal to 4. Okay. You don't need to include these unless I tell you to, but now you know where they go, right? Like, because I ask you to state them here. Right, this is the blue line, and this is the red line, right? And maybe it's also important to know that this is the vertex, and it's 2, 4, right? It's the highest point this parabola will reach in terms of the y values, right? Oh, I didn't read that, Alex. No, we're not doing AC today. Most likely tomorrow, right? On stuff like this. Can you graph, right? Oh, good, Sahib, you're there? So the deal is, folks, if you're late, just tell me that you're here, okay? I know you can't see the chat from before, so you don't know if I did attendance or not, but okay. Okay, Gur Sahib, are you here? Just type here. Making sure you can hear me. Okay. Right on. Thank you, Gur Sahib. Okay, so we have this here. This graph is done. That would be a complete graph with the exception of, right, if you wanted full marks, have the label there, the equation, okay? In this case, it's not crucial because we know that everything in this section revolves around that equation, right? But a full graph, a complete graph would include the equation here. So label would be this, the x and the y, right? That would be a label category. So you would lose half if any one of those is missing. Scale in either direction is also half, and so forth. Okay. Let's do another one here. Let's type that in to our y1. I'm going to leave y2 equal to 0 because I'm going to need it, right? So let's just type in 0.05 x squared plus 2x plus 7. Keep in mind that x, like the 2x could be missing, right? The x term does not have to be there. So is the constant, right? As long as you have something in front of x squared, you're fine. So let's hit graph. Whoa, what's happening there? Right. So let's go back here. We know that this points up because it's positive, right? And we know that this is going to be a wider curve because A is between 0 and 1. Okay, if A is between 0 and 1, it's going to be a wide. So anything in between, right? A fraction that is not greater than 1, and up because A is positive. So because we were able to see a leg of the quadratic, we know it's pointing, we know it's doing this, right? It's kind of, you're going to have a low point here somewhere, right? So now you need to, now this is where your knowledge of window comes in. How do you change a window? So I'm going to go window, and this is what I'm going to do. I'm going to lower my Y min, right? So that I can see more below. And I'm also going to lower my X min, right? So these two variables I'm going to change. So go to window, X min. I'm going to go minus 50, negative 50, right? And my Y min, maybe do the same. I don't mind doing the same. So let's say you flip this, right? Let's say you put the negative 50 in for Y max. It's going to give you an error. As soon as you try to graph it, it's going to say something out of range, can't do it, right? So be careful that you don't mix them up. The min has to be the lowest value of the two. So let's hit graph, and there it is. It's a little bit too much, right? Because if you think about it, the lowest point on your screen right here is y is equal to negative 50, right? So technically, if you split that in half, this would be about negative 25. That would be good enough, right? If you think about it. So you can leave your window, but I'm just going to show you, right? I'm going to go negative 25 for Y min. The X min is pretty good. And so now you're not seeing a whole bunch of nothing, right? Like you see most of your curve, right? Okay, let's find the X-intercepts. Second trace every time. If you want to get information from your curve, second trace 5, because y2 is already equal to 0. And I'm going to go to the left first. That's close enough. And watch, if you just hit enter 3 times, you're going to get it. Okay. So it's negative 36.12, 0. Okay. And there's another one, second trace 5 again. I'm going to travel over to the other side. Close enough. Enter, enter, enter. As soon as you're closer to that point, it's going to automatically draw to this. It's going to pull to it, right? So this is hard to see for you on the screen, but it's negative 3.88 if you round it. Okay? Negative 3.88. And it's 0 there. And I'm not going to forget, I use my calculator. So I'm going to go, it's going to go into my graph. I don't want that too much. So y2 is equal to 0, second trace 5. Okay. So that tells me that you've done the work here. Y-intercept, it is in standard form. I don't see any brackets anywhere. So 0, 7 is it. No need to put keystrokes down. Vertex. Let's go ahead and find our vertex, which is right here. It's the low point. So we have to go second trace minimum, right? We're going to get a minimum out of this. So select that option. You should see it up here on your screen. See, it says that you selected minimum. So I'm going to put my pencil down on the vertex so you can see it says left boundary. So you need to take your cursor and go to the left of it. There we go. As soon as you pass it, you're good. Hit enter. Then go over to the right because it's asking right boundary. Go past it. If you go further past it over to here, it's just going to take slightly longer for it to find it. Not a big deal. Okay, so don't think that you need to be at a certain spot or whatever. So you end up with negative 20, negative 13. Negative 20, negative 13. I'm just going to put down the keystrokes. Second trace, 3 for min, right, minimum. So those are your keystrokes for that. In this case, you have a minimum. So the equation of the minimum, you can only have one of them, is y equals to negative 13. The axis of symmetry is the vertical line. You get it from the x value of the vertex. The domain, I'm just going to do the first one, okay? You already get the point with the interval notation. And in this case, y will be greater than or equal to negative 13, right? Because it gets to the lowest is negative 13, but then it's bigger than that, right? It just keeps on going up. So that should be negative 13, squiggly brackets, or negative 13 to positive infinity. Round brackets around infinity, square brackets around the start. So lowest value first, biggest value second, always. And my window, I went negative 50, 10, negative 25, 10. Right? That's the window I used. It's just for reference. Let's graph this, X and Y. I'm looking at my X-intercepts. I go to negative 36, right? So I need to have at least go down to negative 40 here. And my Y-intercept goes down to negative 30. Wait a minute. Yeah, sorry. My Y-intercept is 7. And my vertex goes to negative 13. So I'm thinking if I go to negative 20 here, then I'm fine. Negative 40 there, then I'm fine. So I'm going to go with a scale of 10. So 10, 20, 30, 40. I'm going to do the same thing here. And I think if I go by fives here, I'll be fine. So 5, 10, 15, 20. 5, 10, 15, 20. Okay. So I'm going to go maybe label every second one. 20, 40, negative 20, negative 40, negative 10, negative 20, 10, 20. So I'm consistent within the axes, right? So I'm going scale of 5 here, scale of 10 here, okay? So let's plot our points. Negative 36 would be right about here, okay? Negative 3.8, if this is 10, then it's like 4 here somewhere in this neighborhood. And then 0.7 puts me right about here. Those are my intercepts, and then the vertex is negative 20, negative 13. This is 15, so 13 is right about there. Okay, and then now you have to be artistic, okay, to make this work. So I'm going to go out and over, and this just keeps opening that way, and kind of try to make this work. There you go. Okay, so that is that for this one. And I think I'm going to skip to question 3 or 4, I mean. Okay, so this is there. Let's go to question 4 because that's where you have the first instance of having to find the Y-intercept using your calculator. Okay, so make a note here, not in standard form. By the way, your booklets have page numbers. I forgot about that. So page number 4, that's what we're on right now. Okay. So just by looking at this, that is still the A value we're looking at. And we know that it's positive, so it's going to be pointing up. And we know that A is bigger than 1, so it's going to be a narrower curve. Okay. And so let's go ahead and type this into our calculator as is. Okay, so we go y equals clear. Okay, so use brackets, 5 bracket x minus 3, right, and then another bracket x plus 15. And hit graph. Oh, there it is. And you can tell that it's a lot narrower than the one we just graphed before, right? So that's what I mean by that. So we can see enough to kind of tell, right? It's pointing up. So we are expecting it that the vertex is down here somewhere because we see both legs of it, right? So let's change our window. So this is what I'm going to do. This goes all the way to -50 right now. So you have a couple of options. Just change your window based on what you already see, or try zoom 6, like standard zoom, to get back to the original and then change it from there. It's up to you. So I'm gonna, -50 is too far for the x min, so I'm gonna go -25. Okay, I'm gonna cut it in half, and I'm gonna just bring the y min down as well. So let's see here. I'm gonna go -25 for x min, and I have a feeling that I have to go at least -50. So I'm gonna double that 25 to -50 here. I'm pretty sure I might have to go lower than that, but we'll see. So those are my Windows settings. Yeah, I expected that already. So watch this, okay? For zoom, for quick window, this is -50. So I'm thinking I have to double that to -100, right? Just by looking at the trend. So I'm going to go window, and it's probably going to be even lower than that, but I'm just kind of walking you through it and trying to get you to see what's happening here. So it's still not working. Okay, so I'm going to keep going. Window. I'm getting tired of this. So I'm going to be like, okay, fine. I'm going to go -300, right? Instead of doubling, I'm going to triple the y min. And then hit graph. And it still didn't quite do the trick. But you can tell that you're close, right? So let's go back to window. Sure, you can go -600 if you want. I think that -500 will probably do it. And there it is. So if you go -500 for y min, but -600 would have done the trick as well, right? So you can see both x-intercepts, you can see the y-intercept, and you can see the vertex. So you're good to go now. So let's go ahead and find the x-intercepts. How about I write down the window settings here? I think I went -25 to 10, and then we went -500 to 10, I believe. And if you wanted to see more above the x-axis, you could increase your y max if you wanted to, but I'm good with this. So let's go ahead and find the x-intercept. Second trace 5. I'm going to go to the left one first. Enter, enter, enter. That's negative 15, 0. And then again, second trace 5. I'm going to go over to the other side. Enter, enter, enter. That is 3, 0. And I'm going to write down the keystrokes. Y2 is equal to 0, second trace 5. Y-intercept, you can't do it like this. Okay, you can't just go get it from your equation. So that's where you go second trace value, x is equal to 0, and it's actually negative 225. So I hope you tried this one. 0, negative 225. Right? The y-intercept is found the same way as you did it with the linear. And we're going to write down second trace 1, x is equal to 0. Vertex, let's go ahead and find that. It's a min again, right? It's a low. So second trace min. I'm going to go to the left, right? Because it's asking for left boundary. Enter. It's asking for right boundary. Travel, enter. Guess, sure. And it's 6, negative 405. Sorry, it's negative 6, right? Yeah, sorry. It's negative 6. Negative 405. And that is second trace 3, right, for minimum. The minimum is y is equal to negative 405. The axis of symmetry is just negative 6. Domain is all real numbers. Range would be y is greater than or equal to negative 405. Or negative 405 to positive infinity. So it gets you to practice everything. Okay. Maybe what I will do is a couple of things here. Maybe let's go arrow down from there. You have to use the calculator to find this, comma, since the equation is not in standard form. So maybe on your study sheets, right? And you should maybe have one that looks like this, right? And then just tell yourself you can't use the calculator to come up with the equation to come up with the y-intercept. You have to use the calculator in order for you to find it. Okay, let's graph this. X, Y. I actually should have given more room here, right? But it is what it is. You can extend it if you want. I'm going to go 100. So 1, 2, 3, 4. I'll go 500 just for good measure. So every marking represents 100 along the y-axis. Okay, so I'm just going to go negative 500 here, 500 up here. My x-axis, I can just go by fives, right? 5, 10, 15, 20. So it's negative 20 here, 5, 10, 15, 20. My answer key might be different. As I said, there's no one right way of graphing because the scale could be different from one student to the other. As long as it's consistent, that's all I need. So the X-Intercepts, negative 15 and 3, 0, so that'd be right about there. The Y-Intercept is at 0, negative 225. So I would say right about there. The vertex is at negative 6. So right about there. Minus 405. So right there, I would say. Okay. And then you just use this and just make sure it opens up. Don't bring it in. Okay, it's not a U. Okay. What else should I say about this? I don't know if you've noticed. Anybody notice the X-intercepts and the equation? A connection there? There's a 15 here. And one of the X-intercepts is negative 15, so they're opposite in sign, but it's 15, 15 nonetheless, right? Then you have negative 3 and positive 3 here coming up. That's actually a guarantee. Like if you see a binomial and another binomial like that, just change the signs of them and you have the X-intercepts, right? So just positive 3, negative 15, those are your X-intercepts. So if you've noticed that, you can go for it, although I would just encourage you just type it in because these can look very different, right? So if you just type it in and use your calculator to find that information, that's all you need. All right. Any questions about this in class or at home? Do we have any questions or any concerns? Like, is there any? Sometimes there are interesting questions out there, and if you're willing to ask, then I can maybe clarify that for you. Just put it in the chat if you're at home. If not, we're gonna continue with our notes. Good question. Yes. So good point. So my answer key apparently has a different window. Oh yes. Good point. You brought it up. It's X-min, X-max, Y-min, Y-max. So I made a mistake on my key. Okay, that was supposed to be negative 520. Okay, if you caught that, good. But you know what? I will never ask you for the window. So it was just there for you to know what to do. So I hope that didn't throw you off too much. Good point. I'm going to fix that here. Yeah. Oh, okay. And Andrea, for question 2, is it better to put it in the slope intercept form? Okay. For question 4, should you turn it into slope intercept? Slope intercept is only for linear equations. Okay. I think what you're trying to say is turn it into standard form, right? Where you have the ax squared bx plus c. I would recommend just keep it this way and type that into your calculator. Do not attempt to distribute and collect like terms. There's a high likelihood of making a mistake, okay? Just keep it in the original. Got it? Okay. Good questions. Any other questions? All right. So finding the axis of symmetry when 2 points are at the same height, i.e. the y values are the same. That's like the topic of today. Okay. Okay, so since the parabola is symmetric, we can find the axis of symmetry as long as we know 2 points that share the same y value. Same height. So you notice that I'm throwing the words, right? I'm mixing it up on purpose, right? Same y value, same height. So the axis of symmetry, if you're trying to find it without a graph, right, is going to be x is equal to x1, x sub 1 plus x sub 2, that's in brackets, divided by 2. Where x1 and x2 are the x values of the 2 points. So here I'm going to give you a little graph. kind of offset it a little bit so that there's more room to the right. Okay, so if you're given 2 points and it's assumed that they're on the parabola, I will just highlight the fact that, right, they share the same y value, right? They have the same height, so to speak. And then we consider the first one x1, and we consider that second point x2. So to find the axis of symmetry, right, the axis of symmetry is an equation which would be x is equal to x1, which is -4, plus x2, which is 5. Put that in brackets. Divide that by 2. You get 1 over 2, which is also 0.5. So either one is good there. For B, right, axis of symmetry. And again, this is x1, this is x2. It doesn't matter which one you call x1 and x2, really. You just have to kind of stick with one. And again, right, you have -4 there and -4 there. So you can do this. You cannot do this if these y values are different, right? Because then they're not at the same height, which means that the distance to the middle is different. Okay, you cannot assume that it's just going to be halfway between these 2 points. So it's 3 plus 7 divided by 2, right? Which is 10 divided by 2. Sorry, this should be axis symmetry like this, and then it should be x is equal to, right, this. And so finally you conclude that 10 divided by 2 is 5, and x is equal to 5 is the axis of symmetry. What if the question said this, like 2 x-intercepts? Find the axis of symmetry, given that the x-intercepts of the parabola are -5 and -3. Huh, I wonder what that is supposed to be. Wait a minute. Okay, are these at the same height, perhaps, you think? What is the x-intercept for? So the x-intercept has y values of 0, right? So yes, they actually have the same, right? So that's -5, 0, and -3, 0. They share the same y values, so you can just say that the axis of symmetry, right, will be found by just adding them up. -5 plus -3, okay, divided by 2. That is just -5 minus 3, because the positive and the negative just go negative, over 2. And that'd be -8 over 2, which is -4. So x is equal to -4. That's the axis of symmetry. Okay, so it's fairly easy to do right now, but then later on, sometimes students forget. Okay. So write that down, and then Also, thank you. If you submitted the survey or if you completed the survey, thank you for doing that. I appreciate the feedback. I take it and try to adjust, knowing also that there's a lot of stuff to cover, right? So I always have to find that balance. Okay. We're good. Okay, so that's finding the axis of symmetry. Now we're going to use this. We're going to use that formula, and I might give you, these two. I might give you the vertex, which gives you this, right? And one of these, and then you can use this formula to find the missing piece. So let's do that. Find the missing value, missing x value given the following. Three, 5, question mark, 5, vertex is 6 minus 10. So the assumption is that all these are on the same parabola. Okay. You notice that they're both at the same height. So you know that, okay, these are 2 points that are at the same height. They're just on opposite sides of that leg, right, of the parabola. We don't know if it's opening up or down. That's beside the point, but we can still apply the same concept of the parabola being symmetric. So this would then be considered my x1. This would be considered the second, right, x2 for that second value, which is across. These are always across each other. They give me the vertex. Out of the vertex, I can take this one and know that the axis of symmetry, right, is x equals to 6. Right? So I do have the x value. I have x1, but I need to find that x2. Okay. Use x is equal to x1 plus x2 divided by 2. Right? So we're going to substitute in. We know that this 6 here is going to be replaced by that, right? So it's 6 is equal to 3 plus x2 divided by 2. So now you need to use some algebra to isolate for x2. So whatever is happening around x2, you do that first. The 2 is affecting this whole thing. So we're going to multiply both sides by 2. Okay. And that gives you 12 is equal to, these two will cancel out, right? Multiplying, dividing, it's like nothing ever happened. So you're just really left with 3 plus x2. You bring the 3 over, subtracting, so it's 12 minus 3 is equal to x2, which is already on this side. x2 is equal to 9. Okay, and you're done. Therefore, second point, is 9, 5. Okay, and this, the 9 we got from the calculation we just did. So these 2 points would have to be at 3, 5 and 9, 5 given a vertex of 6, -10. Okay. I'm running short on time. We're almost out here. But what I'm going to do is I'm just going to assign homework here, 300 at page 368 in your textbooks. Do 1 to 5, 6 to 7, 9 to 11. Okay, and I will just say a couple things here. Yes, this is what I wanted to address here. If you, I'm just gonna look at the screen for a bit, like once you've written down the homework, I'm gonna bump that up a bit. So look at question 2, right? State the coordinates of the y-intercept, which is fairly simple to do, right? You can just either type this in and find it, or just, that is the constant there. And it says, and 2 additional ordered pairs. So what? Pay close attention. 2 additional ordered pairs. Like, what is that? They're asking for 2 extra points that lie on this parabola. Okay, how would you do that? Here, I'll show you. I'm using the fourth question that I just graphed earlier. So just watch, okay? I can find any point I would like on here. You know how I would do that? I go second, trace value, and type in any x value you would like to type in. So let's say I type in x is equal to 2. It finds you just found a point 2, -85. Hey, I want more. Okay, second trace value, -3. You just found the point -3, -360. Okay, so using your calculator, it's actually very easy to do. Just type that in and then use second trace 1, right, to find that any value. Feed it any x value and it will give you a y value in return. Okay, so, and we'll talk about some of these tomorrow. Be ready to graph tomorrow, like the homework questions that I assigned over the weekend. And we'll probably have an AC on that. Okay, other than that,